Welcome to this video on using your TI-84 to perform normal distribution calculations. Grab the companion notes if you were wanting to take some notes on how to use your calculator. Starting from the basic screen, you want to go to this VARS button. So we're going to hit second function VARS, and you see above it, it says DISTR. That stands for distributions. With the stat button and then this distribution, those are going to be the two main places that you're going to go on your calculator for AP statistics. So when you click that second function VARS, the distribution button, you're going to pull up a menu that looks like this. And the first two things on that menu are normal PDF and normal CDF. They stand for normal probability density function and normal cumulative density function. We're never going to use the normal PDF. Doesn't make sense with a normal distribution, so we're going to only use the CDF button for the normal calculations. What the normal CDF button does is it calculates a probability within an area. So when you click on that, you see a lower bound and an upper bound, then your mu and your sigma, so mean and standard deviation. So when we were in our normal distribution video, we had data on the amount of time that pandas sleep on average per day in zoos. And the mean in that was 12, and we had a standard deviation of 1.5. We had a panda that was sleeping 14 hours, and we got a z-score of 1.33. So that would be what you would put into a standardized normal. If you want to know, the area below that curve would be the probability that if you were randomly selecting a panda, what would the probability be that it would sleep less than the panda that you had there? And so you put that in. When you're using the z-score, you would use, because it's a standardized value, you would use a mean of 0 and a standard deviation of 1. And then you hit enter, 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 and you come up with the probability 0.982, which is the same probability we found using table A in that video that I'll link above. So the probability of randomly choosing a panda that would sleep less than that panda would be over 90%. And then since all of the area under our curve sums to 1, the probability of randomly selecting a panda that would sleep more than that panda would be a little over 9%. With normal CDF, you don't have to go to the z-score in order to find the probability. You can go directly from your mean and your standard deviation and then the value that you are looking at. So you could have gone with an upper value is 14, and it is summing up all of the probability up to 14. Why you see this negative 1 to the E99, that's kind of simulating negative infinity in your calculator, some big number. And as long as you have a big number there, it's going to be fine. You could have put like 10,000 there and I think you would get the same probability. So 14 on the upper end, and then we had a mean of 12 and a standard deviation of 1.5, which you can see denoted up here in your graph. And then you can hit enter, 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 and we get a value that's very similar value we found using the standardized value. And the reason that it's different is because when we found the 1.33 z-score, that was not an exact value. We had a little bit of rounding. So there is a little difference there because of that rounding. So last thing that I want to talk about is the probability notations. This P parentheses X less than 14 means what is the probability that you would draw, in this case a panda that slept for less than 14 hours, if you're randomly selecting a panda from this distribution. And that would be over 90% of the time you would choose a panda that would sleep less than 14 hours. All right, I hope that was helpful. See you soon.